Before we go on to a quick test of the P1AM-100 Pro Open controller, I just wanted to quickly show you on the website the additional modules that I mentioned, including the alternate controller, which is a full-blown PLC, relay, ladder, logic, etc., etc. So let's just switch over to that now. Okay, there we go. So you can see here, this is on the AutomationDirect website, where we're looking at the, let me just get in here, programmable controllers. There we go, shop. The one we have, as I said, is the open source compatible controller, but you have other ones available to you. So we have a P1 and a P1 550. These two are Productivity 1000 CPUs, which have up to 50 megabytes of ladder logic, a micro SD card, Ethernet built in. The one we have here does not have Ethernet. RS485, RS232, and a micro USB port as well, and it takes 24 volts DC. Has a built-in battery, I'm assuming for a real-time clock of some kind, perhaps. The P1 550 has two Ethernet ports on it, and then we have some starter kits further down for it. We look at the I/O modules. Just go into here. This is the one we have, which is the Arduino Pro Open, this is the module we have right now. Oh, here's some of the I/O modules now. Discrete input module 8.12 to 24 volts DC, syncing or sourcing. We have a discrete input module 8.24 volts AC or DC, syncing, sourcing. Discrete input 16.12 to 24 volt DC, syncing, sourcing. 16.24 volts AC, DC. Variations on the theme here with all the different modules. Let's have a look. Discrete output module 12 to 24 volts DC. Anyway, you can have a look through this yourself. There's a lot of different modules that you can get. All right, so what we have now is I'm showing you the module. I've hooked up the mains. I've only got the power supply connected to it. I also need to install and configure the Arduino IDE. Now, there are instructions provided for this, so if we have a quick look in here. Okay, under programming, so automationdirect.com/open-source/programming. Again, provide the link in the description. You see we've got instructions for loading the Arduino IDE. This will include bringing in the libraries, etc. for it. And we can also use productivity blocks to program the controller as well. As I said, anything that you can use pretty much to program an Arduino compatible board, you can also use to program this controller. So productivity blocks look like this, a little bit like sketch blocks, etc. Only this one is set up for talking to the P1AM. And you can see here, you just download put in a couple of libraries once you've set it up, and away you go. I'm going to do a simple blink sketch. That's the idea of what I'm going to do anyway, once we figure out what I/O the switch and the LED is on. I didn't have the Arduino IDE installed, so I'm just quickly installing that first. As soon as it's ready, I will get back to you and we will go through how to load the libraries, set up the boards info, etc. Okay, I've installed the Arduino IDE, and now what we've got to do is add the libraries, etc. to the IDE so that we can program for this controller. Now, obviously, as I've already mentioned, it is pretty close to the MKR Zero, but we want to make sure we use the right libraries and everything else for it, and the boards, just in case there's some pin variants and things like that. So there is a link through the productivity page that takes you to GitHub through their forums. It's a sticky in the forums for getting started with the P1AM-100. I'm on that page right now. If you need to know the URL, it's github.com/facts-engineering/P1AM. Again, provide a link in the description. We will go down through this page. You can see there's an example of programming here. It deals with analog inputs, temperature inputs, analog outputs, discrete inputs, outputs, relays, specialty modules like PWM or counters, etc., etc. I did mention that it uses a slot and channel kind of methodology for programming. You can see here a example of that where we're turning on something that's in slot 1 channel 2. We're saying high 1 comma 2, so it's very, very simple here. Now you could obviously use constants and things to put aliases in that would say digital or analog or PWM or whatever that can then map to the correct slot numbers. But remember, the slot, you can put any module in any slot, you just have to remember what slot that module is in so that the programming matches it. What we're interested in right this minute, of course, is just getting the installation completed for the Arduino. So we're just going to scroll down here. Arduino 1.8.7, well, I got 1.8.12 in now. And you go include library, library manager, manage libraries, and type P1AM in the search box. So let's do that first. We'll pop up the, oops, minimize that, we'll get Windows going forever. Start up the Arduino IDE. I don't have the module plugged into it yet, so we'll allow access. I've never ran this before on this computer. Tools, manage libraries, and we put in P1AM, and here we have it. So we have the P1AM-100 CPU library. We need to install that. We need to take the latest one, so that's 1.0.1. Hit install. That should just take a few moments, and that is done. But that just gives us some sketches and examples. It does not give us the board manager. So we'll close this. Let's go back to the instructions. You can also, it gives you the alternatives as well, installing via a zip file and things as well. The next thing is to add the information for the boards library, where you go start Arduino, select file, preferences. This is the same for a lot of different boards. If you've been using Arduino IDE for a while, you'll be quite used to this. So I'm just going to grab this URL, goes all the way to the .json there. I'll copy that. And we'll go back to the Arduino IDE here, and we'll go File, Preferences. And in here, you can see we've got the sketchbook location. We don't need to change any of this. I mean, if you want to override these things and change it to whatever you'd like to use, like sometimes I'll increase the font size, for example. Anyway, what we're interested in is additional boards manager URLs. So in here, we'll just paste that, the thing we just copied in, right that, and we'll say OK. Now, when we go to boards, we should be able to install the board manager, right? So we go to Tools, Board Manager this time, not Library, and we type in P1AM and we will install it. We go Tools, and instead of Manage Libraries, we want to manage the board. So we go, it's defaulted to Arduino Uno. We go to Board Manager, and we type in P1AM again. It should find it this time. So here we go. We install that. This will install pins files and compiler files and various other things, whatever is necessary for driving the P1AM-100. So we'll let that complete its process. I'm not zooming in to show you precisely what I'm typing here because all this information is very clearly laid out in the GitHub Facts Engineering set of files on GitHub, and it looks like they're very, very good. There's a lot of information there for you. So we're just going to wait for this to finish installing. So while we're waiting for that, let's just see if there's anything else in here to be done. I think the driver's automatically installed anyway when we plug it into Windows. And yeah, I guess after that we just pick up a P1AM-100 in examples. Oh, in the user's manual. Yeah, every single one, remember I mentioned on the edge of the modules there's a QR code. So I've got the user manual for the P1AM. And if I go down here a little bit, look at the front panel layout. It's very, very detailed, and they look to be very well written manuals, which is nice. We should find somewhere a description of the front panel, and I believe it tells me the... Is that it? Nope, that's not it. Going down. That's the micro USB connector. Here we go. So that's the module that we're looking to program for the moment. Nothing in there for it. Let's go down a little bit further. There we go. So P1 faceplate layout, page 23 of 69. So the toggle switch is tied to switch underscore built in, and it's on digital pin 31, just in case we need that. And the LED is LED underscore built in or digital pin 32. So theoretically, we should be able to use LED built in and switch built in. We'll see whether that works. Anyway, the Arduino may be not finished yet, still going. There we go, done. So we'll close that. And in the Arduino IDE, I'll pull up, we'll have a look what examples have been provided. Let's just pick the board first. Board P1AM-100, there we go at the bottom. We'll pick that board, and we should be able to find libraries because I did install the library. Examples, oh, there it is now at the bottom. I guess I just P1AM basic. So there's no blink sketch in here, which is a shame, but anyway, you got analog input output. These are using some of the modules, I guess. Toggle switch. That probably reads the toggle switch. Let's have a look. Just to make this bigger so you can see. This is why I often will increase the font size. Let's go back into preferences and up this up to, I don't know, 18 point maybe. Okay, there we go, that's a bit better. So looking at the sketch that we just imported from the examples, we've got setting up the LED built-in output and switch built-in input. So we set those up. Initial switch state is 0. We've got a little loop, standard Arduino sketch. Switch state is digital read, switch built-in, digital write, LED built-in, switch state. So basically what this is doing here at this simplest level is just reflecting the status of the switch. So let me just grab a USB cable and we will plug it into the computer and upload this sketch. Let's just see if it compiles first. Do a verify. Compiling sketch. First time it's compiling the sketch, so it would take a little longer. So 3%, using up 10K of program storage space. Okay, so that's ready. We know that's going to compile. You can see it's including the one library here, P1AM-.h. It's not actually using anything of it, but it may be defining the LED built-in and switch built-in parameters. So let's just stop this a second and I'll go get the cable. Okay, I've got the USB cable. I haven't powered this up yet. I think this may run when it's plugged into the USB without even needing the power module plugged in. But let's plug it in and see what happens. Oh, powered up. Yep, looks like it's going to. I already played with a blink type sketch, so that I was going to be giving you accurate information. But nevertheless, the one I'm going to send you is the one that we had on the screen right now, which is this one. So it should upload it and should just simply reflect the state of this switch. So let's upload that. Shouldn't need, oh, I haven't set a COM port yet. Probably needs that. Yep, COM5, P1AM-100. And we'll hit upload. That should upload quite happily. Compiling sketch, done. Uploading. Done. Okay, so now when I switch this switch, let me just go back to the correct screen. There we go. So the switch is up. No mains on here. So if I switch that, the LED goes off. LED goes on. The LED goes off. The LED goes on. Perfect. Now, if I go grab the other sketch that I did, that was the one that was loaded before, you'll see how easy it is to do something with this, and it's all completely Arduino capable, compatible. So just give me a moment. Okay, here's my sketch. It is based entirely on the blink sketch that comes as standard as an example with the Arduino IDE. Pretty much works for anything. We have included the P1AM header file, which brings in the libraries for the controller. This also allows us to have LED built in and switch built in, defined and pointing to the correct pins of the module. The setup has been modified to use the switch built-in input as well. That's the second pin mode command here. And in the main loop, I've modified the blink sketch to take into consideration the switch position and use that to set a different delay, either 1000 or 500. So it reads the switch, which is this digital read switch built in. If it's true, sets the delay to 1 second, and if it isn't true, sets the delay to half a second. It then goes through and does the turn the LED on, wait whatever the chosen delay is, turn the LED off, wait that delay again, go back to the beginning of the loop, reread the switch, rinse and repeat. So let's just upload that and see if it works. Now doing the compile, I'll flip back to the controller. Okay, put it into programming mode, uploaded the sketch, and you can see now that the light is blinking at about a 1 second period. So if I flip the switch, now you can see it's blinking at the half second period. So it's half a second on, half a second off. So that means what we have is the digital read built in true, that's the 1 second, which is actually up here, so it's open. When you flip it down, the switch down, it's closing the contact, and it effectively becomes false. So now so when I switch it down here, you can see it's going at about a 1 second on, 1 second off. That's obviously using my delay as 1000. So it sees that as true. Flip it back again, and it'll see it as false. Now, let's unplug the computer. That's obviously going to power this thing off. And I'll turn on the power supply. I have it plugged into my safety power supply. So we'll just turn that on. That should actually start things up again. There we go. And we've got 121 volts here. Let's go to amps. So it's actually drawing, well, it's this lower resolution as my little kilowatt can read, 0.01 amp. So if I go to watts, that's 0.8 of a watt that it's drawing right now. Now, it's obviously no great big set of modules plugged in, but you know, that's pretty low power. Anyway, so there's the example of that little sketch that I had. Let me just turn this off again. I've got mains coming into here. And in summary, so what have we done? We've had a look at an overview level of the P1AM-100 Pro Open Arduino compatible PLC controller. Doesn't support relay ladder logic, but it does support pretty much any IDE that would be able to program an Arduino. That would include the Microsoft Studio Code, blocky, various types. There is one specially for the Pro 100. And it would support obviously the standard Arduino IDE, and it will also support the new professional Arduino IDE that is based on Eclipse, I would imagine, as well. Although I'm not sure whether the libraries would need to be modified for that one or not. Probably not. Anyway, it interfaces with all of the standard AutomationDirect productivity open modules, the Productivity 1000 series modules that would all plug in on the right hand side. It also has a series of MKR modules that plug in the left hand side that would give you effectively real-time integration, or at least real-time as far as the process is concerned. Real-time is a funny statement. When you're using a PLC with relay ladder logic, they're effectively determined as real-time, but what it really means is a predetermined time, a known time per cycle, which is often measured at maybe a 100 millisecond cycle time. So it runs through its logic 10 times a second or 100 times a second or whatever it may be set up for, where it'll scan all its IOs, it'll run its evaluation logic, it will update its IO, and then it would rinse and repeat. Gives you a very tightly defined control of your inputs and outputs and makes it very predictable. When you're programming with C directly, then you have to do everything yourself. So it's much more important to understand what you're doing, because if you updated an output immediately you determined that it should be on, and then later in your code something else evaluated that said it should be off, you could get a relay chattering, a fan breaking because you're trying to turn it on and off, dozens of times a second or whatever else. So this is perfectly industrial capable. It is, as I said, CE and UL certified, but because of the nature of the way you program it, you have to be much more aware of what you're doing. When you use the relay ladder logic, it has traditionally been accepted as the way to do industrial control, but there is nothing to stop you using something like this as well, because it opens up a whole bunch of other flexibility. But in the future videos, as we go through each of these modules to have a look at how they work and everything else and do some programming examples, just bear in mind that whatever I'm doing with the Arduino, you can pretty much do with relay ladder logic and things like that. Now, I don't have a version of an AutomationDirect actual PLC to do a comparison with. Maybe I'll give them a call and ask them if they wanted to send me one. Then when we do some examples, we could do a side-by-side. How do you do it with relay ladder logic? How do you do it with an Arduino? But anyway, this completes this video. I think you'll agree this is a quite exciting set of modules to use, and the P1AM-100 presents an extra layer of flexibility for doing your industrial control applications. These are priced at a level that would also make them very favorable for home and office automation projects as well, because you can get relay modules for mains control. You've got lots of 24 volts. You could put external interfaces in for it and stuff like that. You've got an Ethernet module, which means that you could plug this into a local network and have it communicate over Wi-Fi to some remote sensors and things like that as well. I think because it's running using a SAM-D21, you've got plenty of performance for doing even CNC control, motor controls, that kind of stuff as well, even a 3D printer. A lot of the controllers for 3D printers are not even as powerful as the SAM-D21. Maybe some of the new 32-bit ones are, but most of the older ones have been based on the original Atmel 328 or the ATmega 2560, which run only at 16 megahertz. Obviously, if you were going to run stepper motors and things like that, you would probably build a module that would go on the left-hand side of the P1AM-100 and have it directly talking to the stepper motor controllers, even if they were still isolated. Anyway, that's a topic for another conversation, another video. That completes this video for the overview of the Pro Open P1AM-100 and its associated modules from AutomationDirect. Now, if you like the video, give it a thumbs up. If you don't, well, don't. It's up to you. But I will be doing some more. I'm starting a whole series of programming for the Arduino at a beginner level and an advanced and maybe an intermediate one as well. So I will be using this module in some of those examples just to show you the difference in how you may program things. And obviously, when you start using these extension modules that we have available, it changes the way that you do your programming and the way that you think about your programming. So that's it. See you in the next video.